Hello everyone. Today I'm gonna show you how to build a ERC20 token, and we will go over some of the basic things in a ERC20 token startup. I'm gonna use OpenZeppelin, Zeppelin Solidity repository, contract/token, and today version is, they just got released, I think, a day ago, 1.30. So let's go. So let's start with the most basic one, ERC20 basic. I'm gonna copy paste it here in a remix. I'm gonna create a new file. I'm gonna call it ERC20 basic. Okay. So let's see. So this is just the interface contract, so using which we can implement our ERC20 tokens. We're going to use a lot of interfaces, and I'm going to go over it. So the first line is just total supply. It basically means how many total supply tokens exist. The next one, balance of, with a one argument, who, which always returns the balance of the address when you pass the argument. Transfer basically means you want to transfer your token to somebody with some amount of tokens you want to send. And it returns Boolean if this transaction went successfully. And then there is an event transfer. This is basically for logging. That's it. So let's go to the next contract. ERC20, that's all. So as we can see, this contract imports ERC20 basic, and I'm gonna paste it here, ERC20. Okay. Still, this is still an interface because it doesn't have a constructor, which basically means you can't deploy this contract right now. So here we have a few more functions. The first one is allowance, which basically means if you allowed, if you give a permission to someone to manage your tokens on, basically you are the owner and you can check the spender and you can check how many tokens you allowed someone to manage. Transfer from, this is basically, let's say if you're the owner of your tokens, let's say if you have a 1,000 tokens and you gave me permission to manage 500 of your tokens. So with this method, I can, this is intended to execute it from me because you gave me the permission. So if I want to spend your tokens, which you give me the permission for, I should call this method, and I can say from your address to somebody else and the value. Next method is approve. So basically, when you want to give me the permission, let's say, hey, I have 1,000 tokens and I want you, Roman, to manage your tokens. So you have to call this method first, like that you specify my address and you specify how many tokens you want to give me to manage. These methods are mostly used by exchanges. So you just give them the permission and that's pretty much it. And then there is an event approval. Okay, next one. Next one, I'm going to use a basic token. So with this token, we can already deploy our first basic token, which is not going to do much, but you can see the basic functionality. So basic token. Okay, here we go. We also need a safe math lib. I'm just gonna, yeah. Safe math. Yes. And I'm gonna copy it from here. Contracts, math, safe math. So that is it. And basic token, we're just gonna say import from relative directory. Okay, I'm also gonna bump the version to 15. So let's see what's going on. So basically the basic token is inherited from ERC20 basic, which means it has to implement every method that was defined in the interface. So it has to have all those 3 methods and those 2 methods. So basically 6 methods and 1 public variable. Okay, let's see. So this line means we are going to use safe math lib for the unsigned integer 256. So we can do some basic calculations, and to make sure we're not going to do some overflows. You can read the code for the safe math. It has a few methods: multiplication, division, subtraction, and addition. Okay, so this is mapping. This is basically a hash map. It shows we want to see the balance of someone. Like, it's not public variable, so it just stores the balances of every token holder. Transfer. This is what I explained you earlier, that this is the method which will be called by token holder when you want to transfer your tokens from somebody. When you want to transfer your own tokens to someone, and you have 2 variables, to and value. You can read the implementation, but it's basically straightforward. It's making sure that the transfer is specified. It's not 0. The message sender, then it does the actual calculation right away. So if this fails, or you don't have that, that's why we're using safe math. It will actually fail if you don't have it. So it's totally safe to use this kind of line. And then we assign the values to the new token holder, and there is a event happening just for login purposes and return true. That's very basic. Then balance of is just basically a function to query how many tokens do I have if I want to know like the real balance. And it just returns the access the hash map with your own address. And you can query balance of anyone in Ethereum network because it's public, it's constant, and you can see, okay, I want to know how many tokens my friend have. If you know your friend's address, you can see how many tokens he or she has. So we can deploy this token. Let's select the basic token. And here we go. And that's it. We can't do much. We can assign ourselves tokens. We don't have any tokens. We don't have any total supply, so you can't do anything. That's why it's called basic token. Let's go next. Let's do something more fun. Token, and let's say we want to deploy mintable token, which I already showed you before, but I didn't really explain what is it and what's going on in this. So let's copy this code. Say mintable token. Okay. Oh, I missed the standard token. Let's see what the standard token is. Okay, this is the standard token. We're gonna copy this into Remix. Now I'm gonna call it standard token. Okay. Okay, so the standard token is using basic token implementation, is inheriting from, and ERC20 token interface. So let's see. So this one has more additional functionalities. So we actually, in basic token, we don't have any methods for like approve or do something like that, and using allowance. So that's why we already can see that there is additional hash map and a hash map where we track on who allowed to who and how much. So that's why there is a method transfer from, transfer tokens from one address to another. But don't be confused. This is to be called by allowed people. So again, as I explained you before, if you allow me to manage your tokens, then I should call this method. And as you can see, this is the checking the allowance. If you allowed from your address to me, we can check whether how many tokens you allowed me. If you didn't allow me any tokens, then this amount will be 0. Okay. This is basically the same thing. And the only exception that they also track that to decrease the allowance that you provided. The approve method, so if you want to give me the permission to manage your tokens, you should call this method with my address and how many tokens you want me to manage on behalf of message sender, yes. So allowance is basically a public constant function. So any public constant function could be called by anyone. There are no restrictions, and basically it returns you some value. So there are two arguments. So if you want to check when you allow someone to manage the tokens, you can check if the amount is correct when you call. So you basically pass your own address and the person who has a permission for your tokens. Then there are two additional methods, increase approval and decrease approval. So if you decided to give more power to the person who you want to give permission to, you can call this method. And the same thing for decrease. So that is standard token. We can also deploy it, standard token. But again, we can't do much because total supply is 0, balance is 0. We can only do like some stuff with approve. Let's say if I want to approve this address, so if I want to give approval of this address with 1,000 tokens, I can call this function, and then I can check. So the first argument is owner, which is me. And the second address, the person that I just gave permission to manage 1,000 tokens. And we can see, yes, this person can manage 1,000 tokens. But since we don't have any tokens, we cannot check any other. We can only decrease and approval or increase or decrease approval. We can call transfer. Since we don't have any tokens, we can call transfer from as well. Okay, that was a standard token, so anyone can deploy this token, but you can't do much because you don't have any functionality. So, which brings us to a mintable token that we already have here. So a mintable token is using standard token. It's also using some very standard common pattern called ownable. let me show you what ownable is. It's basically to manage ownership of the token. I mean, not only token, just for any contract. So I'm gonna add here ownable. Okay, so now let me go over very quickly. It's very simple contract. It has an ownable. It keeps track of who the owner is. It has only one event when you transfer ownership. When you deploy this contract, it automatically assigns the owner to the sender. So this is the modifier which is often used in many contracts when you want to only give a authorized control of a function to only a owner. And then the function transfer ownership. That's it. There is nothing else here. I'm just going to remove comments for the sake of simplicity. Okay, so now let's go to mintable token. We have these two contracts which we already went through. So mintable token is a standard token and it's ownable. We have two events. I usually don't explain events because events don't do much. They only just track the log information into the blockchain, so you can read the history of all the transaction like activity within your contract. It has one variable, public variable, minting finish, which means when you can stop minting the token. It has one modifier, can mint, which is very explicitly named, whether you can mint the token or not, which checks this variable above. So when it's true, this is going to throw an error when somebody is going to try to mint more tokens. So then we have this function mint, which is very explicit. You specify who is going to have some tokens and how many tokens you want to mint to a particular address. Only owner can call this function, only if the minting is not finished and it's public. So what it does, it increases the total supply, it assigns the balance to the person who is going to have new tokens. Then it runs two events, mint and transfer, return and true. That's it. That's how you mint tokens. Now we're going to have some fun with this token. And yeah, and one more function to finish minting. So if you decide to stop scamming your people, so make sure, like, sorry for using the word scam because I believe many people know what I'm talking about. So if you want to check whether you want to buy some token, you can check if they have stopped minting. Basically, if they stop minting, they cannot issue you any more tokens. They can only sell what is available from the total supply. If the total supply is 0 and minting is finished, then no one can have any tokens. So let's deploy this contract. I'm gonna close all the other ones. Okay, so we just deployed mintable token and we're gonna have some fun. So let's mint some tokens to myself. Let's make sure, like, so you can see that I do not have any tokens that we're gonna call the balance of. It should return 0. Cool. So now we're gonna mint some tokens. I'm gonna mint 10 tokens. Now we're gonna check. We have 10 tokens. I'm the owner of this contract because only I can mint. If we change the sender and we call mint more tokens, we're gonna get an error, invalid opcode, because we're calling this mint function from non-owner. only owner can call this function, which basically means this. So then we can approve, however, to this second address, to this address, say, I want to give approval to this address in amount of 5 tokens. Cool. Now, this address, oh, sorry, it didn't go through because I calling from this address, and this address doesn't have any tokens. So we have to call from the account that has some tokens, which makes sense. So now we're gonna call approve. Then we can check. So the owner is this address, and this is the person that has the permission of, yep, he can manage 5 of my tokens. And so let's say you give me permission, and now I'm a bad guy. You give me the permission, and I want to take over of your tokens. So I'm gonna call transfer from your address to my address. And I want to take your 4 tokens. Oh, I see the error because I did a typo there. Let's call transfer from. Okay, cool. So now I just assign 4 tokens. Let's see the total supply. 10. Allowance 1 because we took four tokens from your address to my address, and now we can check the balance of from this guy 4. That's it. Now I have 4 tokens, and you should have 6. Cool. This is working as expected, and we can transfer now tokens. Since I have 4 tokens, we can transfer you back. So I'm going to transfer back because you came to me and said, okay, where's my tokens? I'm like, sorry, I just gave it to myself. And we're going to transfer them back. So now you got your 10 tokens back, and we can check that I don't have any more tokens. 0. This is basic token contract that you can, that's how people use a mintable token for crowd sales when people don't know what would be the total supply. So there are 2 strategies for the crowd sale. One strategy would be not to limit total supply of the token, and they just mint, but they could have a cap on a crowd sale in Ether amount. So if the Ether amount is, let's say, 10,000 Ether for the crowd sale, and they specify some exchange rate. So let's say for 1 Ether you receive 1,000 tokens, and that's how you calculate your total cap, which will be so if the total cap is 10,000 and the exchange rate is 1,000, so your total supply of your tokens would be 10 millions of your tokens. With exception that if you have 18 decimals in your token, which is something else. Okay, that was a mintable token, and I believe that's not it. I believe that, oh yeah, there is also safe ERC20 token, which is basically it's a library, so you can use like using. So I can show you, give you an example. If we take this contract into mintable token contract, and then since it's a library, I can specify in the mintable token contract that using save ERC20 for ERC20. Yep. So now, whenever we're gonna call transfer, or I think now instead of calling transfer, we would have to call the super transfer. Yeah. Okay, so I'm trying to remember, when do we specify name, decimals, and symbol? Because those are 4 additional fields that you have to specify when you do a... Okay, we have an example of simple token. Yeah, here we go. So as you can see, this contract is using the standard token, very simple one, with 4 additional fields. You don't have to specify initial supply, because it could be 0 if you're using mintable token, because mintable token will increase your total supply at the time of minting. So if I just put those 4 lines into my mintable token, then I would have a fully compliant token contract, ERC20 token contract at this moment. So we can call Roman Storm token. We can have the symbol RST, decimal 18. So let me explain what this means. That means so in an Ethereum world, you have something called way, and basically what it means is that how much way, let's say from way, one way in Ether amount. So this is 10 in 10 in power 18. This is the same thing. So one way equals 0. In a 18 power of 10. So that's if you want your token to be like 0.001, that means you only want to have 2 decimals. So if I put 2 decimals, I would not be able to have like 0.001. If you just, but my recommendation to go with 18, because it's just easier for calculation and using your token somewhere else, because that's the standard that Ethereum has, 18, and we can call same functions if we want to calculate like, so in Ethereum, everything's stored in way amount, I mean in unsigned integer 256, and whenever you have the balance, you have like crazy balance. So if I were selling tokens and you send me like 5 Ether for the crowd sale, and my exchange rate was like something like 1 cent, and the 1 cent in Ethereum world, it would be like, so for the 1 token, I should give you, what's the price today? So the price today is 261.86. So if I'm selling you my token for 1 cent, I should give you 26,000 tokens if you give me 1 Ether. 26 RST equals 1 Ether. So now, what happens if you send me like 1.3560, something like that? Then I should calculate you, or if you send me like 10 Ether or even more, we have a crazy large number of like something like that. And now, how do we calculate how many tokens, how many actual tokens in applying your decimals? So we would have to do something like this. That's how many tokens you have when you convert it from way to Ether. and it's very convenient for developers to do that when you have decimals 18. That's it. Sorry, maybe I'm a very horrible teacher, and let me know. But now we have built a fully compliant. We haven't built it yet, so let's do that now. Let's do a mintable token. Create. Here we go. Now we have a symbol. We have the name. We have total supply 0, and minting finished false. We can mint some tokens now very quickly. So that's kind of tokens are most contract used. I mean, they have to have all this functionality in order to be tradable and supported by most Ethereum wallets and exchanges. So mint this amount, we call mint. Okay, now the total supply increased. Yep. That's it for today. Thank you for watching.